the second half of the homework and the review on transformations, we're going to cover our other two. We are going to look at dilations and rotations. So dilations is when a shape grows or shrinks in size. So we have some shape, then that exact same shape in the same manner just becomes larger. Same triangle, just something larger. With dilations, the shapes are not congruent, they end up being similar, which means same shape, different size. When we go to actually perform a dilation, it's almost all occurs outside of the graph. So we don't really have to plot a single point usually to get our graph to work. So we want to dilate the triangle by a scale factor of 3. Or actually, I'm going to change that to 2 because 3 won't fit on the graph that I've placed here. And so what happens is the scale factor, which is denoted the letter K, is the number that we're going to multiply all of these terms by. So starting with A prime, we take 3, we multiply it by 2, we get 6. Take 4, we multiply it by 2, we get 8. There's our new A prime point. So the first point A is at 3, 4. A prime is now at 6, 8. Okay, so point B becomes B prime. 2 times 2 is 4. 2 times 2 is 4. So B is at 2, 2. Right there. So now B prime is at 4, 4. C was at 5, 4. 5, 4. We have this triangle. C prime becomes 10, 8. And if we compare and contrast these two triangles, notice that they're the same shape. They've got this flat edge on the top. They've got these two slanted edges at the exact same angle. If I were to grab this triangle, you can see that it's the exact same. You can also see that this scale factor has affected everything, not just the points. This edge between A and C was 2 squares long. Now it's 4. That scale factor of 2 is still very much apparent. We're going to try one more. This time with the dilation factor of 1/2. Meaning in this problem, our triangle is going to get smaller. So we'll go through, I'm going to plot the original points. Negative 2, 2. Negative 4, 8. Negative 2, 6. Here. Alright. So this one's V, U, and T. With the scale factor of 1/2, we are going to multiply, once again, by this fraction. So in this case, since it's just 1/2, we can just be more like, alright, what's half of these numbers, which is pretty simple. But what's happening is we're going to multiply it by that fraction. And when we multiply fraction, top times the top, bottom times the bottom, we end up getting negative 2 over 2. Negative 2 divided by 2 gives us negative 1. Positive 1. For instance, let's say our scale factor was 3/5. And I wanted to multiply 5 and 15. We take 5 times 3/5. We get 15 over 5. 15 divided by 5 would be 3. We take 15 multiplied by 3/5. We get 45 over 5. We end up getting 9. So even if it's a different fraction, we still multiply the top divided by the bottom. Going through to finish it out, we have u prime gives us negative 2 and 4. V gives us negative 1 and 3. So negative 1, negative 1, or negative 1, 1. There's t prime. Negative 2, 4 is u prime. And negative 1, 3 is v prime. Once again, the exact same shape, just smaller. Skip that one. Moving on to rotations. This is when a shape was spun around a central point. This one was definitely the hardest of our transformations, a lot to keep track of. So with rotation, we do have a center of rotation. For us, that was the origin. You have an angle of rotation, 90 degrees, 180, 270, 360. And then we had a direction. Clockwise or counterclockwise. Which we will have CW, CCW. All of this is needed to perform a rotation, but we're back to having congruent shapes. So we take a rotation, whatever the new shape is, it is congruent to the old one. So I'm going to plot our shape here, 2, negative 2, that's L, 5, negative 4, M, and 3, negative 4, N. And I want to rotate it 180 degrees. Well, from what we remember in class, every 90 degrees, the coordinates switch places. So if we go 90 degrees, we now have the top one still 2, 2, 4, 5, 4, 3. Now we have to be careful in what quadrant they're all in. So we don't necessarily know. Right now we're just worrying about them switching. So after another 90 degrees, which from the beginning is at 180, they've switched back. Now the top doesn't change too much, 2, 2, 5, 4, 3, 4. So that's the order of the coordinates. 90 degrees lands them in one of these two quadrants. So 180, no matter which direction we go, that's why we didn't have to specify, lands them up here in quadrant 2. So what we're going to do is we're going to take these coordinate points and we're going to plot them within quadrant 2. So that means this 2, this 5, this 3 all have to be negative. And so we have negative 2, 2, negative 5, 4, negative 3, 4, label our letters L, prime, M prime, N prime, and we now have a 180 degree rotation around our central point, the origin. Try it again. So we have our points 1, 3, that's R. We'd have 2, 5 for S, and 4, 2 for T. We're going to perform a 90 degree clockwise rotation around the origin. So 90 degrees means that these coordinate points switch places once. Over here on the graph, clockwise rotates this way. So 90 degrees lands us in quadrant number 4. And in quadrant 4, all of our y coordinates are negative. And so we have 3, negative 1, 5, negative 2, 2, negative 4, and there are our points. This one being R prime, this one being T prime, this one being S prime. 90 degree clockwise rotation.